What is up, mathematicians? Happy Tuesday. Uh, Today we get to start chapter 10, which is quite possibly my favorite chapter of this book because it deals with solving quadratic equations by methods other than factoring, and it's all going to lead us up to my favorite equation, the quadratic formula. And you might remember that this is, in fact, the formula that I have tattooed on my bicep. So you get to learn how to use that formula on my bicep. And maybe, just maybe, if you're cool enough one day, you could probably put it on your bicep. If you're not as cool, maybe on your calf or something like that. But anyway, let's get into it. So today we're going to practice working our way up to that by solving quadratic equations by what's called the square root property. So just in case you don't remember quadratic is one of those trinomials that can be some number x squared plus some number with an x plus some other normal number that you set equal to 0. Typically, before we factored these, making those two sets of parentheses and then setting each factor equal to 0. So today we're going to do a different process, a little bit easier, and some of the answers. Why, you might ask yourself, why are we learning how to solve these a different way? Well, if you remember, some of those equations were not factorable. So this method that we're going to work through will be able to solve any quadratic equation, even if it isn't factorable. The answer is not going to look very pleasant, but it's solvable. Okay, so what is the square root property? The square root property says that if something squared equals something else, then x would equal the positive square root of a and the negative square root of a. So let's practice that. So what the goal is here is to get the squared term by itself, and then you're going to take the square root of both sides of the equation. So if we're looking at one like number 1 here, to get the squared term by itself, we would add 9 to both sides of the equation, and x squared would equal 9. So once you have that squared term by itself, you would do the opposite of squaring. We know the opposite of squaring is to square root. The square root and the square cancel each other out. Now when you take the square root of an equation, you get the positive solution and the negative solution. So we write that like this, plus or minus, positive or negative. What's the square root of 9? 3. And why is that? Why do we get two solutions? Well, remember, a quadratic with equation 2, or with an exponent of 2, always gives us two solutions. So what this means, by the way, we have 3 and negative 3, but we write it as plus or minus 3 because it's a little quicker to write than this. So you'll see that both of those work. 3 squared is 9. 9 minus 9 is 0. Negative 3 squared. Negative 3 times negative 3 is also positive 9. And 9 minus 9 is 0. So both positive 3 and negative 3 work, so we write it this way, plus or minus. So anytime you take the square root of an equation, we're going to write plus or minus whatever that square root is. So here we'll see the same thing. Add 16 to both sides. X squared equals 16. The opposite of squaring is to square root. So the square root and the square cancel each other out. When we square root an equation, we get plus or minus the positive and negative version. What's the square root of 16? 4. Okay. So those are nice and easy. They get a little tougher on 3 and 4, but not much tougher. To get x squared by itself, this time we would divide by 2. Now 2 doesn't go into 7, so it's going to stay that fraction of x squared equals 7 halves. Okay. So we have to square root both sides of the equation. Now this one takes a little bit more effort. We know we're going to have plus or minus. Now the square root of 7 and the square root of 2, neither of those are perfect squares. So how do we simplify that? So remember, we can separate it into two separate fractions, and we can't have that radical in the denominator, so we got to simplify that by multiplying by the square root of 2 to the top and bottom. So on bottom, we would have the square root of 2 times the square root of 2, which of course is the square root of 4, also known as just 2. So remember, the square root of 2 times the square root of 2 is 2. On top, the square root of 7 times the square root of 2 is the square root of 14. There is no perfect square that divides 14, so that's as simplified as it gets. So it's plus or minus the square root of 14 over 2. So both irrational answers. So that would be one you couldn't have factored, and we wouldn't have been able to solve it. But now we know that we can solve it. And once again, the answer doesn't look great, but it is the answer to the equation. If we look at 4, it's going to be much the same. Divide by 5, and 5 doesn't go into it evenly. So we're going to take the square root to get rid of the square. And we're going to go ahead, and we know that we're going to have to separate it out. So we're going to say plus or minus the square root of 13 over the square root of 5. To rationalize the denominator, we multiply by the square root of 5 to both the top and bottom. So we would have plus or minus the square root of 65 over normal 5. Is there a perfect square that divides 65? No, because the only way to make 65 is 5 times 13 or 1 times 65, and neither of those are perfect squares. All right, cool. So those are nice and easy. Now 5 and 6 are actually easier than 3 and 4. You'll notice that the squared term is already by itself. So we're ready, even though it's a binomial being squared, we're ready to go ahead and square root both sides. So if you remember back in chapter 7 or whatever it was, we would have had to have FOILed that out, subtracted 16, and then tried to factor what was resulting. This is a lot easier. We just square root both sides. The square and the square root cancel each other out. And that's going to give us x minus 3 equals plus or minus 4. Okay, so then to get x by itself, we just add 3. So add 3, and we're going to write it like this. 3 plus or minus 4. Now that means we can actually do that math. So we do the 3 plus 4, that gives us 7. And then we do the 3 minus 4, that gives us negative 1. So that's a lot less work than having to FOIL that out, subtract 16, refactor, and then set the factors equal to 0. Just 2 easy steps to get our solution. Let's do it again on 6. Take the square root of both sides. So x minus 5 equals plus or minus the square root of 36 is 6. Add 5 to both sides of the equation. So x would equal 5 plus or minus 6. So we can do that math. 5 plus 6 is 11 for our first solution. 5 minus 6 is negative 1 for our second solution. Okay. So when we get perfect squares that are able to take the square root, we get normal looking solutions with 7 and 8. We won't have perfect squares, so we won't have super nice looking answers, but actually it's maybe a little less work. Square root both sides on 7. X plus 1 equals plus or minus the square root of 8. Now let's look at the square root of 8. Is there a perfect square that divides it? So we want to simplify that. Remember, the square root of 8 is the square root of 4 times the square root of 2. So that's going to be really plus or minus 2 square roots of 2 if we simplify the square root of 8. So x plus 1 equals that. And then to get x by itself, we just simply have to subtract 1 from both sides of the equation. So x is going to equal, sorry you can't see that, negative 1 plus or minus 2 square roots of 2. Now since these are not like terms, we can't really put those together. That's going to be our final answer. So on 5 and 6, we were able to put them together because they were both normal numbers. Since this one has a radical attached to it, we can't put it together, so our answer is negative 1 plus 2 square roots of 2 and negative 1 minus 2 square roots of 2. But we just write it this way because it's less writing and it's much quicker to write that. Number 8, this is a great time to pause the video and try that one, see if you can do it. Otherwise, here we go. Square root both sides. X plus 2 equals plus or minus the square root of 12, but the square root of 12 is 4 times 3, so really that's 2 square roots of 3. Subtract the 2 over, and you would have negative 2 plus or minus 2 square roots of 3. Again, we can't do anything with that, so that's going to be the answer that we provide. A couple more, four more problems here. This one, square root both sides. Those cancel each other out. X minus 1 equals plus or minus, oh, look at that. The square root of a negative number. You should remember that you can't take the square root of a negative number. Can't take square root of negative number. So what happens in this case? Now later on you'll be able to solve that, but for now we don't know that as tools. So if you take the square root of a negative number, it's going to be no real solution. In Algebra 2 you'll find that you can, but not yet. Just be happy with this for now. It's actually not too hard to take the square root of a negative number, but we don't have those tools yet. 10, again, let's square root both sides. This time we do have that positive number, so it's going to be fine. Square root and the square cancel each other out. 5x minus 2 equals plus or minus the square root of 10. Now there's no perfect square that divides 10, so that's just going to stay like that. So what would we do next to get x by itself? We would add 2 to both sides. So 5x would equal 2 plus or minus the square root of 10. And then what do we do to get x by itself? We divide by 5. And if we divide, we have to divide everything by 5 over on that side. So there's our solution. X equals 2 plus or minus the square root of 10 all over 5. And we can't reduce, remember we can't reduce the 5 and the 10 because not everything's divisible by 5, and really you can't divide a square root by normal numbers anyway. 11 and 12 are a lot like 9 and 10. Try those if you want. Pause the video. Otherwise, here we go. Square root both answers, or both sides, excuse me. 3x minus 5 equals plus or minus the square root of 17, which does not simplify. Add 5 to both sides of the equation. 3x equals 5 plus or minus the square root of 17. Divide both sides by 3, and that's going to be your solution. 5 plus or minus the square root of 17 all over 3. Number 12, you square it both sides and you stop right there. Because of that, you can't take the square root of a negative number. No real solution. You like those problems. Okay, the last type of problem you'll see is a few pretty simple word problems. They're going to give you some formula. They're going to give you some information. You're going to plug some things in and find the answer. All right, so let's read this situation. The record for the highest dive into a lake was made by Harry Frosbos of Switzerland. In 1936, he dove 394 feet from the airship Hindenburg into Lake Constance. To the nearest tenth of a second, how long did his dive take? Use the formula h equals 16t squared, where t is time and h is height. So there are two numbers in this problem. 1936 is a date. It has nothing to do with this situation. 394 feet is how high he dove. So what variable would that get plugged in for? High, height, must be the h. So 394 equals 16t squared. So I'm going to be solving this for time, which makes sense because they asked me how long to the nearest tenth of a second did his dive take. Now since I'm solving for t, I'm going to flip this equation around and say 16t squared equals 394. Now remember, we want to get the t by itself, so the first thing we would do is divide by 16. So I'll pull out my calculator again. Let's see, 394 divided by 16. Okay, it doesn't go into it evenly, but that's okay because we're rounding our answer to the nearest tenth of a second. We'll just leave it as that decimal. We don't want to round it yet either, so don't round it. 24.625. So how do you get t by itself? You square root both sides. Now, normally you would get plus and minus, right? So let's take the square root of that. 4.96. But this is time. You can't dive, you can't be jumping for negative 4.96 seconds. You in fact would be jumping for positive 4.96. So we reject the negative answer because it doesn't make sense, and then round it to the nearest tenth. This actually rounds to about 5 seconds. All right. Let me know if you need any help with your My Math Lab assignment. Otherwise, good luck. It's not too bad today. See you later.